Welcome to Alaska Level 1. In this lecture we will be discussing mineral groups. So far there are about 3,000 minerals that have been identified. The most common minerals are called rock-forming minerals because they will come together and form rocks on the Earth's crust. The 10 most common minerals on the crust are the following: quartz, orthoclase, plagioclase, muscovite, and biotite. These are silicate minerals. We also have calcite and dolomite. These are carbonate minerals that will fizz with acid. Halite is salt. Gypsum, often found in chocolate. And ferromagnesium minerals. Fe stands for iron and magnesium. So these minerals have iron and magnesium. Examples are olivine, pyroxene, and amphibole. These are all dark minerals. You will be identifying some of these minerals in our mineral lab in this unit. The first mineral group we're going to talk about is the silicate mineral group. This group is the most common mineral group out of all of them. All silicate minerals are going to have silicon and oxygen in the chemical formula. If you remember from the last unit, the two most abundant elements in the crust are silicon and oxygen. Take quartz for example. Quartz is a very well-known rock. In its chemical formula it has SiO2, has silicon and oxygen. Olivine also has silicon and oxygen. Biotite, muscovite, and feldspar also have oxygen and silicon in their chemical formula. Here is feldspar. Feldspar is a common silicate mineral. This has cleavages. We've got a nice cleavage here and here. Mica is another common silicate mineral. This has one plane of cleavage, so you see it's breaking off into small little flakes. Pyroxene is the dark mineral here. Here's an example of quartz that has fracture. And olivine is typically a dark green mineral. Native elements only have one element in their chemical formula. In other words, one capital letter. So some examples are silver, Ag, copper, Cu, graphite is just carbon, and sulfur is sulfur. The next mineral group we're going to talk about are the sulfides. Sulfides have sulfur in their chemical formula. Sulfur is just one capital S. So some examples are galena, which has excellent cleavage and breaks off into cubes, sphalerite, chalcopyrite, which is also similar to pyrite, which is fool's gold, and cinnabar. Sulfates is the next mineral group. Sulfates have sulfur and oxygen. 8 is a suffix which means pertaining to oxygen or having oxygen. So sulfates have sulfur and oxygen. Barite has SO4, so sulfur and oxygen. Gypsum also has SO4. Oxides is the next group. Oxides have oxygen and a metal. So hematite, also pronounced hematite, has iron and oxygen. And here's a picture of one. Corundum has aluminum and oxygen. Here's corundum. And this is an excellent example of a mineral that has cleavage in hexagonal prisms. Ilmenite, iron, titanium, and oxygen. The next mineral group are the halides. These minerals contain halogen elements such as chlorine, fluorine, bromine, and iodine. One example is halite, which has sodium and chlorine. Halite is table salt and has excellent cleavage. Fluorite has calcium and fluorine. Fluorite looks very similar to quartz. An easy way to tell the difference is doing a hardness test. Carbonates have carbon and oxygen. Remember, the suffix -ate means oxygen or pertaining to oxygen. This is a fun group because they fizz with acid. If you pour acid on them, they'll fizz and bubble. Calcite has calcium and carbonate, CO3. This is what your bones are made out of, which is why your bones are white. Milk also has lots of calcium in it, which is why it's white. Another common example is dolomite. Dolomite will fizz, but not quite as easily as calcite. Malachite and azurite are often found in Native American jewelry. Malachite is green, and azurite is a teal blue. An interesting fact about malachite, the Statue of Liberty is oxidizing and turning into malachite. This is why it has a greenish color to it. We're going to move on from mineral groups and talk about crystalline structure. A crystal is a natural solid with a definite internal pattern, which means all of the atoms are arranged in a very specific way. If a set of atoms are arranged in a cube, typically then the crystal will be in the shape of a cube. If the atoms are arranged in a pyramid, the crystal will be in the shape of a pyramid. Silicate minerals have what is called a tetrahedron structure, which means there are 4 oxygen atoms and 1 silicon atom. The 4 oxygen atoms arrange themselves to look like a pyramid, and the silicon atom is stuck in the center. There are 6 main crystal shapes. The first one is isometric or cubic. Iso is a root word meaning the same or equal. Metric is a root word meaning to measure. So all 3 axes measure the same or are equal. This will give us a cube. Orthorhombic has 3 axes. All of them are different lengths, but they're all measuring at 90-degree angles. Triclinic has 3 axes, all of unequal length, and they are not at 90-degree angles. Monoclinic has 3 axes, all unequal length. 2 angles are going to be at 90 degrees, the third one at not a 90-degree angle. Hexagonal will give us a hexagon, so the most common is quartz. Tetragonal, this will give us a pyramid type shape.